Hello, our project is the image editing Chrome extension, and our team is the Server Sonics by Joey, Mimi, Audie, and Cassidy. Our co-designer is a part of a program called Lab. Lab is an educational program that helps students with special needs. Our co-designer likes visiting places in the community and taking strolls. He also likes exploring sensory objects like a rain stick or a spiky ball, spending time with family and friends, and listening to music. Our co-designer has a therapist, which allows us to communicate and get to know our co-designer better. Our co-designer's conditions include seizure disorder, asthma, and encephalitis. Because of encephalitis, he has no verbal communication, global delays, cortical vision impairment, and decreased motor abilities. Our objective is to provide our co-designer with a way to process high-content media, such as images and videos, that make it easier for them to pay attention.
Our first iteration had all the code, the server, the user interface, and the image editing scripts running in one place. As for utility, the code could get the image link from the website and send it to the Python server, and then the Python server could send the image link back to the website. There were no image editing functions. In our second iteration, we changed our organization to a full stack organization, where the server, extension, and image editing code were put in separate places. This made the code run smoother, faster, and better. We also had the high contrast image editing scripts and the machine learning algorithms created, but they were unattached to the extension. We also looked into moving from a local server to a global server. So we created a Docker image for the server, and we're looking for free options to deploy the website. In our third iteration, we regressed back to having the high contrast editing script directly inside the extension, and then the server and machine learning code were just separate and unattached. This was because we faced difficulties integrating the code together in the tight deadline and finding a free service to deploy our website.
In the original goal, everything was compartmentalized so that the extension communicated with the server, which then ran the image editing scripts before everything was sent back to the user. In our current product, the server is separate and the Chrome extension directly communicates with the high contrast image script. So this is how our high contrast image script works. When it is activated by the high contrast button, the high contrast is turned on and we retrieve all the images on the page, get the pixel data, and edit each pixel. After each image is edited, the images on the original page are replaced with our new edited images. This color map in the bottom right shows how each pixel is edited. Using the hue, saturation, and value color values, each hue is rounded to the intervals shown by the grid, making light pixels lighter and dark pixels darker. Conversely, if the high contrast is turned off, then the page is reloaded so the images are reverted. As you can see, the images become more high contrast. So for example, if you take the soccer ball, the lighter colors become lighter and the darker shaded parts become darker.
Unfortunately, we did not get a chance to fully integrate our machine learning model into the Chrome extension. However, we were still able to build a model that masked out an image. Here's what a predicted mask looks like without any training, and then here it is with one iteration. Our finalized model consists of 20 iterations for a better predicted mask. Here we are using the saved model and turning the predicted mask into a NumPy array and changing the pixels based on the values to be black or white. Here's an example of an image where there is a black background and a white outline around the subject. And here's an example with just a black background. Here are some future plans we have for our project. We want to do more testing to get more feedback from our co-designer, since unfortunately we weren't able to meet with them as often as we hoped. We also want to integrate all our parts, for example, the machine learning model, into the Chrome extension itself. And third, we want to make our project more scalable and compatible with other browsers. Throughout this challenge, we learned many things. We learned how to train, test, and save a machine learning model for the first time. We learned how to create a local server to communicate between the server and our extension and the process of running the server globally. And we learned how to communicate with each other and work together as a team in order to get things done. Thank you for watching.